chapter 7. We are actually kind of still in review mode. The first part of chapter 7, as a lot of you know because you typed in the code listings, deals with arrays. Second part is vectors. And when we get into vectors, all of a sudden, we're going to see a word static for the arrays, and we're going to see the word dynamic when we talk about vectors. And what I mean by that is static is we have to pick an array size. And a lot of you know that that can be a problem because I might not have enough memory, or I might have way too much and I wasted a lot of memory. Dynamic means I'm going to use what memory I need. And for those of you that take the next course, we do a whole lot of work comparing static to dynamic and which one works for new abstract data types that you'll be learning. But some of you are like, I won't be there, so I don't need to worry about what he's talking about. Like Melissa, right? You won't be. You never know, you might change your major. But I already know she needed just 161. Okay, so talking about arrays, we'll go in a little more depth, and we'll go through and see some differences, a big difference coming up, and mainly similarities to what we had with arrays, or with what we had back in Java. So what's an array? Array values are stored in consecutive memory locations. The couple examples in the old school were mailboxes that were side by side. Okay, you had one address, and then you had all the mailboxes at that address. Well, we're going to use that same idea, and we're really going to make an emphasis on this word address, because this is going to come up and it's going to start to stick with us more and more. And we just came off of a new idea with our reference variables in the last chapter. And that's when we passed the address in to a function, and then we were able to manipulate the values within the function. So all of a sudden that ampersand, and that was a good question on the test about squaring two values, and it was actually 3 lines of code. And if you have questions about it, you can ask me, but it was using that ampersand. Okay, so I have an array called int, or array called scores, and it's going to hold ints, and I need so a whole bunch of information that you didn't have before that we're now going to take on a higher level is, as soon as I see this, scores, the name scores is going to actually hold the memory address. And when we get to chapter 9 in this class, we're going to get a lot deeper into memory addresses. But for right now, I want you to understand that scores is like a reference variable where it just holds an address. Sort of like our string variables of old did. They held a starting address. Okay? How did we know a string ended? Well, it was that secret delimiter /0. And in this class, we're going to talk about C strings, and we'll get into that a little bit more. Okay, I'm starting to bore myself right now. So let's get back and stay on topic. Scores holds a memory address right there in memory. Coming back up here, I know that I need 10 blocks of size 4 bytes. So when I see int, I'm saying, hey, I need to store 4 bytes to represent each possible score. And that gives me that range of numbers from like -4 million to 4 million or something like that. It was 2 to the 32nd power cut in half. Does that make sense? Yes, no, maybe. We talked about some of that, right? Early on in this course. Yes. Okay. So when I get ready to do this, I'm saying I need 40 bytes of memory at a certain location. You find a location I can use, we'll call it scores, and I'm going to put these 40 bytes. Okay. Scores sub-0, and this is the way I want you to think of it, says go to the memory address, take 0 times 4 bytes, and that's where I want you to be. And that puts me right here at this beginning. If that was a 1, think of it as going to scores and then moving over 1 times 4 bytes, which would move me over to where my second subscript would start, which would move me to this memory location. So start to think about it that way, because later that's going to become really important when we compare arrays to vectors, about moving over those blocks of 4. Okay, so a little bit more than what you had back in 121 with an explanation of what's going on. Implicit initialization. You saw this in 7.3. If we were writing a program and I said, I want you to fill an array with the number of days of each month in a non-leap year, the last thing you would want to do is fill the array with 31, 30, 31, 30, 30 or wait, 28, 31, 28, 31, 30, 31, 30, 31, 30. I'm counting on my knuckles. You all know that one, right? To count on your knuckles. January's 31, 30, or 28, excuse me, 31, 30, 31, 30, 31, 31, 30, 31. So it goes by knuckles, and you could, well, you don't want to do that every time. Have to remember the whole knuckles trick. Instead, we can assign those values directly into the array in the beginning of the program. And that was called implicit initialization. And you saw that in code listing 7.3. Sound kind of familiar? Let me call you sweetheart. Pow! There it is, right? Implicit, I'm giving the values right away. I'm using set notation, the set of numbers. And that, again, that follows my knuckles. So you type that in, it's called implicit initialization, and you should be good to go. Something that's new that we didn't see much in Java is something that's called partial initialization. Kind of the same thing, but I can start to fill my array with, you know, a certain number of values that I know may need to go in there to get started. And that was code listing 7.6. Ta-ta. All right. I have an array of size 7, but I'm only filling the first 4 elements. It's legal. It's good. We like it. Don't know if I have ever used it. Well, I can kind of say that, yeah, no, I never did use it. The next notes I have, I want to talk about.
Excuse me, I have a question.
Yes.
Is it possible to like fill what's called partial initialization? Like what's it called? The slots that, but they're not in order. So like instead of I fill in the first 4, I fill in like every other one. Is that possible?
No, that's a no. Yeah, you can't do that.
Oh.
So only got to fill in from left to right. And we're going to see some things with parameters later where you can do some crazy stuff with a function, and it has 5 parameters. And when you go to instantiate an object, blah, 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 you only have to pass certain ones in. So something that's going to be similar to this is coming up a little bit later as well. I want to point out code listing 7.7. The more I look at it, I'm thinking in the spring when I teach this class, I want to include this because this is one of those that's meaty and it has some good stuff in, and this is going to happen a couple of times in the near future. And what I'm talking about is this while statement in line 17, where I have 2 possible conditions going on inside of it. And the first one is count is less than array size. Oh my, look at this. I like this. I open up a file. I know how big my array is, and I want to read numbers in up until the point of how big the array size is. So that first condition on the left side, my relational operator, while count is less than array size, that means I'm going to not try to put in the subscripts I don't have. And check this out. This is awesome. Okay, you tell me, what is going on here in this right side? Input file greater than numbers count.
Is it saying as long as there are numbers to input, then this would be true?
And
Import them from the file?
nope, somebody give me the second part of that. So this says I want to keep going and I don't want to exceed my array size. This says as long as there are values in the file, keep inputting them and
adding them to the array.
right, storing them right into my array. So it's filling the array as well. So this has, I want to make sure I don't mess up my array by checking, make sure it fits the array size. This little guy says, as long as I have more, I am going to input it and I'm actually going to store it in my array. And the count just keeps going, so it helps me fill the array. And woohoo! When I'm done, I close the file, I display everything in the array, and it looks like it's stored in the first 10 numbers. Could have been 1,000 numbers in there for all we know. But this is one of those pages where down the road, if you had one of those little sticky things with the arrows you could put in this page and mark it, that would be a really good one to mark.
So for that one, if the file only had 5 numbers, it would just stop there.
Yep.
The second condition
Yep.
would be false. Okay.
Right, because this part becomes false, which takes the whole thing as false because of the and. Yes. All right, I like that one. Okay, so code listing 7.9. In Java, if you tried to take an array of size 5 and add 7 items into it, or even 6 items, you got an error. And what was the name of that error? Anybody remember? No, because I always wrote my code right and I never had that problem. Well, that's good. That's good. But sometimes you would get an error that said exception index out of bounds. This isn't a basketball game. What's going on? An exception out of bounds error. Well, that's cool. But guess what happens in C++? Well, the language is going to let you screw up. So if you have an array of size 3, and you saw this in your code listing 7.9, and you try to put 5 numbers in, it's going to stick your 5 numbers in. We don't know what's going to happen after that, but it lets you put the 5 numbers in.
Is there a good reason why C++ lets you do that?
No. Nothing that I've ever heard or could think of. It's kind of bizarre, actually. Maybe Java just spoils us. By your second course, you should be a good enough programmer. You don't have this problem. How's that sound? That's for a reason why. Okay. So again, we're looking at some similarities. This is something, this bounds checking, it's similar, but at the same time, it's different because it just doesn't let you go in. All right, code listing 7.10 comes up with something that in my CPS 121 class, I didn't cover because I thought you had enough on your plate. So having only the 28 days minus 2 for test, it was one of the things that was cut out. But as you can see, it's now included in this class. So it's something that you can do in Java. It's something that you can do in C++. Do you have to do it? No. Every summer I go to Kansas City, except this past one, and grade AP computer science tests, which are the high school tests. And they are in Java, which is why our first language is Java. Because anybody that gets credit for the high school AP test for computer science gets credit for our class. But I see about 50% of the students, when they work with the loop, will actually work with this ranged base loop. Okay, it's a loop that iterates once for each element in the array. So as long as there's elements in the array, it keeps going, and each time it's going to copy it to a variable. So if you take a look at this guy for int val and numbers, this is the example from 710 where numbers is the array. Numbers is the array. And as long as there are values in this array, it's going to take it and store it in val and let you see out val. My see out has 2 T's on it, doesn't it? That's not so good. Okay. You had code listing 710 you typed in. 711. Nice, he has an example that's a little bit different. For this array, it's filled with strings, and I declare my first part, my value that I want to store it in. I declare it as a string so that each time through this loop, each string from the array planets gets stored. I don't know how many of you looked at 712. What's going on with 712? I'm using this. Oh, well, let's see. If I go up to the top, I'm going to cheat. This program uses a range-based for loop to modify the contents of the array. Give it to me in a different wording. Dumb it down for me. A lot of times I need people to dumb it down. What's going on in line 12? It's a loop, but what's happening? David, did you have it?
Yeah,
Go ahead.
setting up an integer, and it's referring back to it with a reference, and then put in from the numbers.
You got it. Say it again. A little clearer for me.
I said it's setting up the integer for value, but it's also a reference going back for it, and then it's getting the numbers for it.
Right. It's setting it up that I have my in val. I'm gonna right now val is related to numbers, but it's listed as a reference value. So when I use it, it'll go to that location because remember it's the ampersand val right now is holding the address of the first item in numbers. Okay, ampersand val. It's so what the first thing in the array before was the value got stored in val. This time, the first address is getting stored in val. So this is the address of that. So when I get ready and seeing a value for val, it's storing it at that address. So this is kind of a backwards way, it almost seems, to fill an array. And then again, here it is going the other direction. I'm getting the actual value at that memory address and displaying it. So this is allowing me to manipulate my array. Kind of clever. And again, some of you will buy into that. Some of you will be going, no, I have other ways to do it. I can do a for loop from 0 to less than 5, and I can ask for it, and I'll see in number sub whatever my loop control variable is. Okay, so this is really the same as for, and I'm going to do counter equals 0, counter is less than 5. Okay, and then what's going on inside my body? I'm saying C out, and then I'm saying C in numbers. sub counter. I'm using the loop from 0 to 5, saying enter a value seen, and I'm storing it at number sub whatever. And again, this is the next level, and we're going to start getting into a lot of this memory address stuff. So that ampersand val becomes important. Questions? Okay, going to stop the recording because now you are going to go and play.